Well, he's gonna load it up first.
Okay.
I'm loading it up first. All right, so right now, we're at 10 amps on that
Is
power
that what
supply.
that's rated at?
I'm gonna go into overload mode. Okay, good, it held up there. Some of them don't do that.
13
Some of them
amps.
crash already. All right, so now that I'm at, I've loaded this thing down, I've dropped from 24 down, so.
Dropped to
You know, the
21,
Phoenix supply was still basically 24 volts. So 23 volts, I've dropped down to 21 volts and change. Now maybe you can crank that up. I guess you could probably crank that up a little bit. Maybe. Maybe not.
That's pretty hard to beat.
Yeah, it might be. Yeah, it might be too big. But in any case, obviously when I put the Phoenix in there, it crashed it, right? And when I went too far, right?
Wow.
At this point, it's I don't know how long it'll hold up because I've never read their specs.
Probably milliseconds. It's only milliseconds.
Well, no, it's holding up pretty good right now.
No, he means with the 13.
With the 13 before it actually crashes.
Can you try it again? Can you pull it back in?
Well, you want me to make it crash? Or, no.
We're testing anyway. It's not a problem.
Well, I mean, here's 10 amps. At 10 amps, it's reading 23.9.
Okay.
And then when I load it into a boost mode,
Yeah.
it starts to drop some, and it starts to drop
Drops,
some there. Now, the point I want to make though is, I don't know how long this will hold up. Ours will do this forever in extended boost mode. It'll still operate 24 volts at 40 degrees C forever.
Just so you get the comparison.
Yeah. All right, so there's the Phoenix.
You know the Phoenix.
When I load the Phoenix up, 14 amps, 15 amps, I'm still basically 24 volts. So
Okay.
I didn't drop in voltage with that overcurrent. So
Now both are going to
now
crash.
if I go into here, you know, obviously I'll crash it down, but I'm right back up. So again, while you're filming here, if I short this circuit breaker, only the one breaker went offline. The power boost shot that boost of current back out and followed its path to ground and took that breaker offline, okay? Now, if I take this power supply out and I have the same fault condition in the field, power supply just crashed. It's crowbar in the power supply right now because you notice no breakers tripped.
No breaker strips.
No breakers tripped. So that would take your entire DC bus down if that was happening out in the field.
Your PLC would crash, everything.
Okay, everything crashed. Yeah, without warning, and we don't know anything happens until you see the red lights on the power supply.
So this power supply, it just took itself off the
Check
line
very
finally.
well.
That breaker just tripped after all that time. But I don't know if that was probably because the thing's overheating. It's running short through that breaker all that time. So that's what happened. The breakers, it won't even reset. There you go. It had to cool down to reset because that breaker's had that short on it the whole
Thermal
time.
load.
So
You're still in the short
Mr.
circuit.
Westbrook, do you understand what we just simulated?
Can you simulate it again?
You put in overloaded, and you never had the
All those breakers
design
are still
feature in
there.
Phoenix. We will basically isolate the problem and shut that breaker down. This TDK.
put the Phoenix back in.
All right.
The biggest
Yeah, I'm gonna
trick,
hit
the
again.
trick is your guys' PLCs are on these
Just took that
24 volt
breaker off
supplies in
line.
a lot of cases.
Voltage stayed
So when
up.
that power supply goes down, that means your whole process goes down, whereas
It's very
if you had
interesting.
something